Welcome to this episode of the PrairieLand Advantage. Our topic today is 9000 series conventional combines, and we are going to be discussing the optimization of the cleaning shoe area of the machines. We want to make sure your machines are working as best as they can. And you'll note from our index that we recommend making adjustments from the front of the combine to the rear because what happens is that adjustment up front can affect an outcome in the rear, and you need to understand the process. So as you can see as our index here, if you want to learn about tailings elevator, that would be close to the end of the video. Well, thank you for joining us today. I'm Drew Lowry.
And I'm Dave Thiessen. And first off, we'd like to start off with a video explaining and showing how the system works internally to give us a better idea of the theory of operation.
Now, let's look at the cleaning system. Material from the cylinder and concave is delivered to the cleaning system by auger conveyors. The augers are located under the concave where the greatest grain load is received. They run in deep troughs, so even when harvesting on slopes, grain is moved in a steady flow. No matter what crop you're harvesting, the principles of the cleaning system are the same. Grain is delivered in high volume onto a pre-cleaner sieve behind the augers and ahead of the chaffer. A constant blast of high-velocity air is directed to the front of the pre-cleaner element by dual-flow cleaning fans. Notice how this high-velocity air lifts and removes heavy chaff from the grain the moment it drops from the augers. The pre-cleaner's job is to efficiently start cleaning the grain before any material reaches the chaffer and sieve for final cleaning. It also allows some clean grain to pass through the openings and go directly to the clean grain auger, another pre-cleaner benefit. The unique dual-flow fans of the maximizer also direct a blast of high-volume air back through the chaffer and sieve area. This air further suspends the material as it comes off the pre-cleaner and goes onto the chaffer. The material is suspended, allowing the grain to rain down through the chaffer. Lighter trash material is suspended and moves out the back of the combine. The same situation in corn shows the kernels quickly passing through the chaffer to the sieve and onto the clean grain auger. Chaffer, sieve, and pre-cleaner adjustments are made from the rear of the combine using the adjustment tool provided. The pre-cleaner should always be adjusted to the closed position in all crops except corn. If the pre-cleaner's louvered vanes are open, air velocity is weakened and heavy chaff is not suspended. Chaff mixed with grain can fall through and go directly to the grain tank. It's important to understand that the openings in the pre-cleaner and chaffer work along with air velocity. This is what happens in wheat when the fan speed is set too low or the chaffer opening is too wide. The material is not suspended and the grain rides out the back of the combine along with the heavy chaff. The same crop with the fan speed set too high or chaffer too tight results in air velocity so great that it blows both the chaff and the grain out the back. The net effect is the same as with low air velocity. Adjustment of the fan speed is easily made from inside the cab. Use the recommended settings found on the handy adjustment card stored in the glove box for a starting point.
As mentioned in the videos, we have the shoe auger bed that pulls the material from underneath the concaves to the main cleaning shoe and the pre-cleaner. On the left-hand side, viewed from the front of the machine, looking underneath the concaves, we see the shoe auger beds and the shoe augers themselves. On the right-hand side, we have an example of the shoe augers that have a plugged and have tunneled out from underneath the concave debris from wheat and small grain chaff and material that's built up. This is blocking the concave's throughput capacity and allowing that material to fall down. And also the shoe augers then are not able to pull the material effectively towards the chaffer and the cleaning shoe area. This is something I'd want to maybe check daily during my harvest season. If I was in some damper conditions, maybe a shower came through or the morning dew, if I got started too early or ran late that evening, this is something that we've seen happen. Also, preparing for harvest, check the previous crop residue and make sure that our chaffer and our pre-chaffer and cleaner up front are all clean and not with crop residue stuck on it from the previous crop. And also just double check and look at your chaffer condition and the lower sieve, looking through the top chaffer down through and looking at the lower sieve to make sure all the wires and louvers are all in place and nothing's broke out or missing, so we can have a good cleaning effect.
One of the things you heard in the video is that air velocity matters. So let's talk briefly about our quadriflow cleaning system. The yellow number 1 is showing the air duct that delivers air to the pre-cleaner. Now this volume of air is high velocity, low volume, and what that does is start the process of lifting that chaff and blowing it out the rear of the machine. The yellow number 2 on the bottom shows the large velocity, low speed volume that is most of the air. So what that's going to do is supply air to the chaffer and sieve. And what that is going to accomplish is give us a good suspension of that chaff once the pre-cleaner starts raising it. Now, as the video mentioned, there's a card in the armrest that mentions recommended RPMs. You can see here between 1,000 and 1,050 RPM, depending on which machines you have, would be great places to start relevant to running your fan speed. Dave, is there anything we need from your years of experience that we need to be watching in this area?
Well, in illustration number 1 there, the red circle at the top of that illustration, I'd ask that they take a look at their air duct and make sure that that's still in a good conditions and that the fatigue and the years of operation, the air duct is still in its original position, so we have good airflow to that pre-cleaner, pre-chaffer area. The other item to think about is down there in number 2, where the large volume of air is flowing towards our chaffer, and that cleaning fan and the quadriflow cleaning fan system, to make sure that if we've harvested crops in muddy conditions, sometimes that mud dries and gets loose and shakes across or moves across or gets stuck in those rotary cleaning fan rotors, and that will cause the paddles to break off or become out of balance. And we've seen some failures from that or lack of airflow causing a cleaning shoe capacity issue that we could have prevented. As mentioned in the video, we've got item number 1 is those shoe augers that are pulling the material out from under the concaves and delivering it to the pre-cleaner, the pre-chaffer. Item 3, as I mentioned, we want to make sure we keep the pre-chaffer closed, pre-cleaner closed for small grains. Anything that falls through the pre-cleaner, pre-chaffer will land in the clean grain auger and go to the grain tank. So we want to keep that closed. There is ample enough airflow through there to start the separation and the lifting process to help the material start to separate as it gets delivered to the main chaffer. Item 2, we have those large quadriflow cleaning system delivering the air to the lower sieve and the top chaffer.
Next, let's talk about how we would make these adjustments. The pre-cleaner, number 4, is on this call out, will need to be closed for everything other than corn. What that's going to do is provide a little bit of air exit, but it's going to direct the larger amount of air back on the primary chaffer, number 5. Number 5, let's talk about the clearance recommendations. 15 to 16 millimeter or near 5/8 inch clearance is the recommended starting point for the chaffer louvers. The sieve, on the other hand, number 6, is going to be recommended at 5 to 6 millimeters or roughly a 1/4 inch. And what that does is that directs the air blast to make sure the chaff is being suspended and exiting the rear of the machine. We used to say that it looked like the machines were air powered when you have your cleaning system adjusted correctly, because the chaff and air are leaving the back of the machine kind of like a jet blast. So make sure that, as the video showed us, that we are setting our cleaning fan speed at the correct amount so that we get the correct results.
An item also to mention here is number 5 is our chaffer that Drew had mentioned, and that's pre-sizing the material that's going to fall through our lower sieve is going to deal with. Anything that falls through and the lower sieve sorts off is going to land in our tailings elevator. So item 5, the top chaffer, we want to make sure we keep those adjustments maybe a little bit tighter than what the book tolerances talk about. And that's why we're suggesting the 5/8 of an inch to pre-size that material. The more we can reduce the tailings volume, the better the machine's capacity overall and the cleanliness of the grain tank sample experience will be. Speaking of the tailings elevator system, here's the examples and some illustrations of the tailings elevator that pulls the crop out from underneath that's been predetermined and pre-sized by the sieve and blown off the back of the sieve, and it takes it back up to the raspar cylinder to deliver it back to be rethreshed. The tailings elevator, if we don't maintain our top chaffer and our lower sieve adjustments to meet our grain tank sample cleanliness that we want, and we have an opportunity that we increased our tailings volume to the point where its maximum capacity is being maintained, it can really, really reduce the amount of throughput volume that you can have on a machine's capacity. And we advise keeping those tailings elevators running as minimal amount of crop flow as you can through there to prevent rethreshing more than we have to.
One of the things that helps our John Deere combines work at their best is having the back end of the machine up a little bit more. Now, sometimes this is done with tire diameters, but if your combine is running level, one way to raise the back of the machine is put the bolts in these blue circles, and that would then raise the rear axle and raise the back of the combine. What that helps us in is the cleaning shoe and the separation area, because the back of the machine is running a little bit uphill, and that will then help the machine to perform better. Thank you for joining us today on our PrairieLand Partners training. Our objective is to deliver the right solution for your harvesting processes.